Hey, you're back. Good. Let's talk about where we were. As I said, back in 1965, these two doctors, Melzack and Wall, had developed their gait control theory, which, like most of our theories on paper, looked great. But how do you put it into practical use? Well, back then it took actually a couple of years to do it. But in 1967, that same Dr. Wall teamed with another doctor, William Sweet, to try and replace the physical stimulation we all get from rubbing and shaking and squeezing our thumbs or fingers or whatever hurts with low-voltage electrical stimulation developed through small needles connected to a battery. Now here's the kicker. Unlike today's trials where people are paid to test out theories, these guys actually tried it on themselves by inserting those needles into their own facial nerves just underneath their eyes. And about the same time, another doctor named Norm Shealy also thought that electricity might be the answer, so he partnered not with another doctor but with a graduate engineering student named Thomas Mortimer, who designed a more fully implantable system that still used a battery, an external battery, connected to similar hypodermic needles, but they in turn were connected to an electrode that was surgically implanted just underneath the skin over the spinal cord in that dorsal horn area we were talking about. And just like the Wall and Sweet facial nerve experiment, this one worked as well, only through the spinal cord. Now, when I say they were implantable, remember, everything's relative. This was 1967, which meant that comparing Shealy and Mortimer's device to today's advanced precision and penta devices from Boston Scientific and St. Jude is like comparing Pong and Pac-Man to SimCity and SEAL Team 6. But as I said, rudimentary as it was, it worked. In fact, it worked so well that the two paired with Medtronic, which at the time was, I think, one of the biggest medical device manufacturers of the day, to redesign Mortimer's creation by applying Medtronic's already successful low-voltage cardiovascular technology to their spinal cord stimulation unit. And in 1968, Medtronic made the first spinal cord stimulators commercially available to the public. All right, so that was 1967. Let's jump ahead almost half a century to today, when newer companies like St. Jude and Boston Scientific and really a whole host of others, they've all joined the race to provide patients with devices that are so technologically advanced that they deliver not only pain-reducing neuroelectrical therapy from completely implantable devices, batteries and all, but they're custom tailored to the patient's exact needs, because just like, what do I know, saddles, for example. Just like saddles, one size doesn't fit all. Here's the fun part. Take this lead, this simple little, what's called a paddle lead. At one time, it was little more than that metal needle that Wall and Shealy were using to pinpoint the specific nerve fibers of their patients. But today, St. Jude Medical, for example, has this pentalead with 5, 10, 15, 20 individual separate electrodes, each one connected to a miniature implantable battery that regulates the amount of electricity that flows to them. Why? Well, brighter minds than mine tell me that when you're talking about neurostimulation, we're talking about targeting specific nerve fibers that are only about 9 or 10 microns thick. That's like 1/10 the size of the average human hair. And even though we're targeting specific bundles of these nerve fibers, those bundles could be literally anywhere within the larger spinal cord. And because it's important to cover all the nerves in a targeted bundle, being able to place a 20 electrode paddle like this one over the general area where the nerves are and use them to close in on the exact nerve fibers the doctor wants by varying the intensity of the current that flows to these electrodes, that's incredible. It's called mapping. And it's the difference between a custom fit saddle or a suit or a new pair of boots and anything that people talk about being off the rack. I mean, generic is fine, but custom, you know what? That's really hard to beat. Now, another fun thing, Boston Scientific. They have their own unique lead structures as well, but they also have their Precision Plus system that has a battery, as you can see. that excels in advanced power, and it's about the size of a $50. Now that may not sound like much, but believe me, in laptops and lumbars, smaller really is better, especially when it's planted under the skin. And with a new proximity-based charging system that works something like the Duracell Power Mate, that square that you just drop your cell phone on and it automatically charges without even being connected. This battery is rechargeable for like 5 years, even if the battery gets completely discharged, which usually makes other batteries useless. And it uses smart technology. Smart technology gives patients wireless control over their own level of stimulation, within, of course, the limits the doctor sets. And finally, it's electronically self-compensating. What does that mean? That means it automatically adjusts for the inevitable changes in impedance that come, or the reduced power that come from the electrical impulses that reach the nerve fibers as human tissue grows around the electrodes, as happens with everything. It's called scar tissue. These batteries are so smart, they self-compensate for it. And then there's Medtronic, whose own 1968 invention has continued to evolve to the point where its newest technology, active stim and restore sensor, I believe, uses motion control and sensitivity, like what lets your cell phone reorient itself when you turn it sideways to recognize changing body positions, only this recognizes human changing body positions, and it automatically adjusts the strength of the electrical impulses that are being sent to your nerve fibers. Standing, sleeping, walking, bending, their technology is designed to keep the situation and the stimulation right where the doctor put it. So now when he or she recommends a spinal cord or spinal stimulation procedure, you may not know everything there is to know about neurostimulation, but at least you'll know enough to ask. And when it's all said and done, isn't that what we're all here doing? Trying to put a little bit of informed into informed consent? So now you're ready for the fun part, the actual surgery. You know, I got to tell you, I wish I would have been in an OR when I was going through what I was going through before I actually put that oh so stylish gown on.